Good morning. I hope you're having a great day. Happy Friday, and I hope you have a great weekend. Thanks for working hard today, and here we go. We've been working so far on solving equations. Hopefully this is mostly review. But what we see today is an equation that looks just a little bit different than what we've been doing. Remember, we've been kind of stepping it up. So this is a step up from what we did last time. Take a minute and look at it and see if you see what's different. If you noticed that there are variables, or x's in this case, on both sides of the equation, that's the thing that's different today. And so when we see variables on both sides of the equation, we're going to follow the general rules that you see posted there on the left side of your screen. It doesn't mean that we will do these exact steps every time, but generally this is the process that we will follow. So step 1 says simplify each side. That means combine like terms or use the distributive property, but try to get each side, the left side of the equal sign and the right side of the equal sign, to look as simple as possible. Second of all, we want to get all of the variables either on the left side or on the right side. It doesn't matter, but they all need to be together. And we use inverse operations, typically addition or subtraction, to make that happen. The third thing we'll do is the same process, but this time getting all the numbers on the opposite side. And so we'll use inverse operations, typically addition or subtraction, to get our numbers on the opposite side. Once we've done this, it should look like a normal equation that we've been solving, and so we'll then just continue solving using inverse operations of addition, subtraction, multiplication, or division. So let's jump in and get started on this first one. When I look at this first one, I notice on the left side, I have some like terms of 3x and 4x. And so I'm going to combine those together, 3x plus 4x. Remember, the sign always goes with what is immediately after it. And so 3x plus 4x becomes 7x. I still have that minus 10 with nothing to combine with, so I'm just going to leave that on the left side. So I have now simplified the left side of the equation. Coming over to the right side, I see parentheses, so I'm going to distribute in, and it is a negative 2 that I'm distributing, so negative 2 times x is negative 2x. And negative 2 times negative 4, negative times negative, turns it into a positive 8. And then I still have that plus 9 that's not affected by the negative 2 because it's not in the parentheses. Now, I'm not quite done with number 1 because I can still now see that I have some like terms of numbers on the right side that I can combine. And so when I do that, I get negative 2x plus 17, and I leave what's on the left side, 7x minus 10. All right, now I'm ready to move on to step 2, which means get all of the variables on one side. If you'll notice, I have a 7x on the left and a negative 2x on the right. And so to get them on the same side, I either need to subtract 7x from each side to remove it from the left and put it on the right, or add 2x to each side to get the 2x to move. I personally like to keep things positive if possible, so I'm going to add 2x to each side. And when I do that, I end up with 9x minus 10 is equal to 17. All right, now I'm ready to move on to step 3, get the numbers on the opposite side. And so since I have all the x's on the left side, I'm going to work on removing all of the numbers. So since it's minus 10, inverse operations would say I need to add 10 to each side. And I have 9x is equal to 27. And then finally, step 4, solve with inverse operations. If I want to isolate or get the x by itself, I ask myself what's happening to the x. It's being multiplied by 9, so the inverse operation would be to divide by 9. And I'd end up with an answer of x equals 3. Guys, anytime I can check this answer to be sure that it's correct by plugging that 3 in everywhere I see an x. So if I came up to the top, 3 times 3, that would be a 9. I'd still have the minus 10, and 4 times 3 would be plus 12. If I did 9 minus 10, that would be negative 1 plus 12 would be 11, so the left side is an 11. Over on the right side, I would do the same thing, so I'd have negative 2 times 3 minus 4, and then plus 9. And so 3 minus 4 is negative 1, and negative 2 times negative 1 is positive 2. Positive 2 plus 9 is also 11. So since it's true that 11 does equal 11, I can be sure that this problem is correct. Let's take a look at one more of these types of questions. So again, if you remember our steps, our first goal is to get the left side simplified and the right side simplified. And so I see parentheses on the left side, so I'm going to go ahead and distribute n. So 1/2 times n is 1/2 n. And 1/2 times negative 4 is negative 2. Minus 7 is not affected by those parentheses, and so I'm just going to write it down. There's still some simplifying that I can do. So 1/2 n, and negative 2 minus 7 would become minus 9. Over on the right side, there's really nothing to simplify. I can't put together n's with numbers, and so I'm just going to write it as it is, negative 2n plus 6. All right, I'm ready to move on to step 2, which says get all of our variables together. So again, trying to keep things positive, I'm going to add 2n to each side. And I'm going to get 2.5n minus 9 is equal to 6. Now I need to get numbers to the same side, so I'm going to add 9 to each side. And I'm going to get 2.5n is equal to 15. And then I'm multiplying 2.5 times n, so I'm going to divide by 2.5. Divide by 2.5. Guys, is it okay to write it as 2.5 at this point? As long as our decimal is not a repeating decimal or not a decimal that never ends, we can absolutely write it. If it's something that becomes a nice decimal, then we can absolutely write it as a decimal. And so when we divide, we now get n is equal to 6 in this case. And just like before, I can come back up here and plug that into check if I feel like there's something, or if I want to make sure that I've got that answer correct. So I'm going to ask that you pause right now, and you should find on your Google Classroom a link to a Quizzes. It's got 5 questions that are solving this type of equation, and I just want you to take a minute and try to solve each of those equations just to kind of make sure that you're in a good place here. All right, welcome back. I hope that you were able to solve those. If you had a little bit of trouble, make sure you're helping each other out and using your resources. If you did well on those, great. I'm really glad. I wanted to come back and talk about 2 more problems because each of these problems has something interesting that happens with them. And so when we're solving equations, we might have one solution just like we had on the last problems that we've been doing. You solve it and you find out the variable equals a number. But there are also 2 other special cases. One of those being that there's not an answer, there's not any value that the variable can be that would make that equation true. We would call that a no solution. Or we have problems where anything you pick for the variable will work. You could pick any value. And those are called infinitely many solutions. And so we're going to look at those 2 cases right now. So this one, I'm going to follow the same steps that I've been following. I'm going to simplify the left side and simplify the right side. In this case, 4x plus 6, there's nothing for me to simplify there. But on the right side, I can absolutely distribute in. 2x times 2x becomes 4x, and 2x times 3 becomes 6. And so I end up getting an equation that says 4x plus 6 equals 4x plus 6. Guys, I can stop right here and say that this is an infinitely many solution. And the reason that I know that is because it looks exactly the same on each side of the equation. Now, what if I didn't notice that and I was continuing on with my steps of getting now all of my variables to the left or right side? Well, to do that, I would subtract 4x from each side. And by doing that, they eliminate, and I'm left with 6 is equal to 6. At this point, I also know that this is an infinitely many solutions because I end up with no variables left, but my answer makes sense. It's true that 6 is equal to 6. And so that's how I know this is an infinitely many solution. You can try it out. Plug any value you want for x and see if you get a true statement. I think you'll find out that you do. All right, so let's look at one last problem. You can probably already guess what this is going to turn out to be, but we're going to work through our steps just like before. Left side, everything looks simplified, but right side I see some parentheses, so I'm going to distribute in, and I end up with 6x plus 8, and on the right side I've got 6x minus 5. Now, at this point I can't stop and say it's infinitely many because they don't look exactly the same on each side. And so I'm going to move on with my steps of now working toward getting my variables all on the same side. And so I'm going to subtract 6x from each side, and by doing that, 6x minus 6x is eliminated, and I'm left with negative 5 is equal to, again, 6x minus 6x is eliminated, I get it equals 8. Guys, at this point, I know that this is a no solution because this answer doesn't make sense. There is never a time when negative 5 is equal to 8. And so I know that that's a no solution type of problem. All right, so today what I'd like for you to spend the rest of your time doing is I'd like for you to work through the problems on a worksheet. It's really important to me that you show your work. I want to be able to see what you're doing so that if we're struggling in some areas, we are able to go back and look at those specific areas. So work on those worksheets, absolutely help each other out, but make sure you're helping, not just giving answers. Everybody needs to do their own work, and I'd like for you to turn what you have in before you leave today. If you don't finish every single problem, I'm not necessarily going to count that against you as long as I hear that you have been working hard and we're working through each problem. If you need more paper or more space, go ahead and get a sheet of paper out. Just make sure you label each problem that you do. Have a great weekend and a great long weekend, and I will see you when I get back on Wednesday. Have a great day. Bye.